Hello, everybody, and welcome to Chapter 1 for our Nolan textbook, An Introduction to Statistics and Research Design. This chapter goes over some terms and definitions and things that we'll be using more particularly as we move through the next chapters, but this is definitely an introduction. Let's see. So we're going to start with two important terms for statistics, which are population and sample. So a population, when we talk about statistics, is the entire group of individuals that you're interested in studying. So if I was interested in studying the relationship between class standing of students at San Diego State, so freshman, sophomore, junior, senior, class standing, and their academic performance, their GPA. So is there a relationship between if you are a freshman, sophomore, junior, or senior and your GPA? The population that I'm interested in is everybody that I'm interested in studying. So that would mean every single student at San Diego State. That would be the population. If I'm interested in doing a study on perhaps a new medication that I think will help alleviate symptoms of depression in people diagnosed with depression, then my population would be every single person diagnosed with depression. If I'm interested in studying a new behavioral treatment for children diagnosed with autism, then my population would be every single child diagnosed with autism. Usually, as you can tell, populations are so large that the researcher can't examine the whole group. It would be impossible for me to do a study on every single child who's been diagnosed with autism. There are too many. It's too large of a group. It would be impossible. It would be expensive. It would be time consuming, and it just wouldn't be practical. So instead of studying the entire population, researchers typically study a sample. That is a small group that is selected to represent the population in a research study. And the goal then is to take a small group, let's say of children diagnosed with autism, maybe 50 or 100 children, try my new treatment on this sample, on this smaller group, and then use the results from my sample to hopefully answer questions about the population. So if the treatment is effective in my sample, then I want to be able to say, hey, this treatment I think is going to work in the population. So it's this circular pattern where you have the population. This is everybody that you're interested in studying, usually too large to actually do a research study on the whole population. So instead, researchers select a sample, a small group of people from the population. The individuals in the sample participate in the research study, and then the results of the research study are generalized, are used to explain something about the population. So a population is a collection of all possible members of a group. It could be any size. Typically, we're interested in very large populations, like everyone who has been diagnosed with an anxiety disorder, if I'm trying to study anxiety disorders. But it could be a very small population. For instance, if I was only interested in student satisfaction of students in online statistics, Psych 104 classes at MiraCosta College taught by Dr. Spilkin, well, that entire population would be just you students who are enrolled in this class this semester. So 35 students. That's a pretty small population. If the population is that small, I can probably test the entire uh, population, right? I could send you all out a survey and ask how satisfied you are with this class. But typically the populations are much larger that we're interested in studying. So we need to take a sample, a small group, a subset of the population, and then we use our sample results to estimate what we think is happening in the population. And inferential statistics are methods that we use to make these conclusions or inferences, right? Inferential statistics, we make inferences about populations based on our sample data. So that's inferential statistics. And if you look on this next slide, we've got two branches of statistics. We have what we call descriptive statistics and these inferential statistics. And our class is really broken up into these two sections. We start with descriptive statistics. This will be the first, up until the first midterm. We'll be talking about descriptive statistics. Descriptive statistics are used to organize, summarize your data. So once you gather your data, and we will look at this in chapter 2, you have a bunch of raw data, it's in no order, and your descriptive statistics will organize that data. You might use a graph, you might use a table, and then there are some summary measures, some summary statistics you can use, something like the mean or the standard deviation. That'll be the following week. We'll be learning about that. Um, so, descriptive statistics organize, summarize, and simplify our data. After that, we're going to move to inferential statistics. That'll be after our first exam. And these are the statistics that we use to make estimates or inferences about the population based on our sample. Now, if you've never taken a statistics class before, these are probably things you've not heard of before. Inferential statistics are things like z-tests, t-tests, ANOVAs, and that's what we'll be learning about in the second part of the class. And basically, since the sample is just a part of the population, our sample only provides limited information about the population, and we need these statistics to help us make our best inference or our best guess at what we think is happening in the whole population. Another important term is variables. We'll be talking about variables from today till the end of the semester. When you do a research study, you study variables. And variables could be anything. I could be studying income level or aggression level or test scores or voter preference. Anything can be a variable. The key for something to be a variable is that it has to be able to take on at least two values. So there has to at least be two options. Are you married or not married, right? That could be a variable. Are you a student or not a student? Or it can take on many, many different values, right? Like what score people get on a final exam. Well, they could get 100 or a 99 or a 98 or a 97, etc. Um, the only thing it can't be is something that only has one value. If it only has one value, it's not a variable, it's a constant. And variability is really a key concept to all of statistics because we're trying to explain variability. When we do our research studies, we're really curious about why people are different. Our questions are about, for instance, why do some people get higher test scores than others? And there's lots of possible reasons, right? You might think of some as you're sitting here. Why do some people get higher test scores than others? Well, maybe they study more than others, or they're more interested in this topic, or something about their intelligence, their inborn intelligence, or something about they get better sleep or better nutrition. I don't know, there's lots of things. But our question is, why are people different? Why do people get different test scores? Why do people have different levels of depression? Why are some people more depressed than others? Why do some people have more anxiety than others? These are our questions. Why are some people more aggressive than others? So when we're talking about statistics, we're really talking, and our research questions, we're really talking about variability, and variability brings us back to the idea of the variables we study. There are different types of variables, discrete versus continuous. Discrete variables are variables that can only take on specific values, and there's no values in between those numbers. They're whole numbers. For example, how many letters are in your name? Well, you either have 3 letters or 4 letters. You could never have 3.5 letters. That's a discrete variable. There's no fractions, there's no decimals possible. Continuous variables are variables that can take on a full range of values. There's an infinite number of potential values that exist. How tall are you? You're 5 feet. You're 5 feet 1 inch, or you're 5 feet 1.1 inches, or 5 feet 1.12 inches, right? There can be decimals and fractions, and those would be continuous variables. And when we think about a research study, we have to decide how we are going to measure the variables that we want to study. And there are two types of discrete observations and two kind of levels of continuous observations. This is called the scales of measurement for your variables. And we have 4 scales of measurement: nominal, ordinal, interval, ratio. Nominal and ordinal are both types of discrete observations. Interval and ratio are both types of continuous observations. And so we're going to go through the next slides that talk about these in more detail. And this is kind of a summary slide that you could refer back to. In terms of scales of measurement, nominal, if we start up here, nominal gives you the least amount of information about the variable. And as we go down here, ordinal, interval to ratio, ratio gives you the most amount of information about a variable. So these are kind of in order from least amount of information to most information. So let's start with nominal. Nominal, you can also think of as named categories. This is when you assign names to different levels of a variable, and people fall into groups, to named groups. There's actually no numbers associated with a nominal variable. So if I wanted to study eye color of, I don't know, students, maybe I think eye color is related to your personality. Then I would ask you, what's your eye color? And your answer would be brown eyes, or blue eyes, or green eyes, or hazel eyes. And so the data we're collecting are names, are words, right? And we'd have a group of people with brown eyes and a group of people with blue eyes and green eyes, etc. Um, Same with marital status. I could ask, as in my research study, are you single or married or divorced or widowed? These, are you dating, right? These are categories, named categories, and people fall into categories. Are you a student? Yes or no? Again, you're falling into a category. There's no numbers associated with these categories, they're just words. What is your major in college? Psychology, anthropology, biology. You're collecting data, and the data you're collecting is words. Categories, no numbers. As you might imagine, there's not a lot of statistical analysis you can do with words. You can't add up the words together and find a mean. Could I find an average? What's the average uh, college major of a bunch of students? I can't do that, right? I can't add up one psychology plus two psychology plus another psychology plus a biology, divide by 3. I don't know. You can't do it. So you're limited in the statistics you can do with nominal data. Ordinal data, sorry about that. Ordinal means rank order. Okay, ordinal data rank order. So this is if your data is coming in as first place, second place, third place. Okay, now you have numbers: first place, second place, third place. But those numbers aren't the kind of numbers you can do math with. They're not the kind of numbers you typically think of when you think of numbers. they give you some information. If we think about TV show popularity, we know that whatever was the first most popular show in a week had more viewers than the second most popular show that week. And we know that the second most popular show in a week had more viewers than the third most popular show. But we don't know anything about the size of the interval between the numbers. We don't know the difference between first and second and third. And in fact, they may be very big differences. If it happens to be the week of the Super Bowl, that's probably the first place most popular watched show by a lot. And then whatever is the second place show, I don't know what it might be, is probably very far behind that. And then the third most popular show, I don't know, it could be pretty close to the second most popular show or not at all. We don't know. And then if the week that we're talking about for TV show popularity is not the Super Bowl week, maybe the first and second place shows are very close together. Almost the same amount of people watched the first and second place show. And then maybe the third place show was much farther behind. You don't know anything about the size of the intervals. And because of that, you can't treat these like regular numbers. You can't do math. You can't add a first place and a second place equals third place, right? You can't do that with these numbers. They give you some information, but not a lot. Interval and ratio are very similar to each other. There's only one difference that distinguishes if your data is interval or ratio data. And truthfully, when we do our research studies, we pretty much consider interval and ratio data the same. We kind of call it an interval/ratio category of data. And this it's important. We all have to learn the difference between it. But then when we are actually using data, we kind of consider them about the same. So let me start with interval. In interval data, you're getting your score is an actual number. So yay, we have numbers. And these are numbers that you can do math with, which is nice. You're assuming that you have equal distance between the numbers on whatever scale it is that you're using. The typical scale we use to describe interval data is temperature. So if you imagine a thermometer and temperature, and if it's 70 degrees and then 71 degrees, that difference between 70 and 71 degrees is 1 degree. And if you happen to be at 84 degrees and you go to 85 degrees, the difference between 84 and 85 degrees is also 1 degree. It's an equal amount of increase in heat, no matter where you are on the scale, or if it's somewhere where it's 2 degrees. Oh, I feel bad for you. If it's 2 degrees and it goes up to 3 degrees. Again, you've gone up 1 degree, and that it should be an equal amount of an increase in heat no matter where you are on the scale. So we assume equal amounts between the numbers on the scale, and that's a key for being able to do some kind of math with these numbers. The only thing that is a little bit of an issue with interval scale is that we say there is no true zero. What do we mean by that? Well, what does zero mean mathematically? Zero means nothing, right? Or the absence of something. There's nothing there if you have zero of something. But if you think about temperature, if you get to somewhere where it is 0 degrees, and I'm not sure if some of you have been somewhere where it's 0 degrees, what does it mean when you're at 0 degrees? It doesn't really mean, in fact, it doesn't at all mean, the absence of temperature. 0 is just another point on the scale. 0 is a temperature, it's a very cold temperature, but it doesn't mean nothingness. It doesn't mean the absence of temperature, right? When you get to a ratio scale, again, people get your data is number data, and there are equal intervals between points on the scale. but there is a true zero. Zero means zero. Zero means nothing, the absence of. Zero on a scale of weight means it weighs nothing. Height means that if 0 inches in height, or the height is nothing, it has no height. All right, and so you can really, those are actual real ratio numbers that you can do math, you can create ratios, you can do everything you need. As I said, for our purposes in behavioral sciences, we typically consider interval and ratio scales pretty much equivalent and do the same types of statistics. Because a lot of our psychological tests, things like depression and IQ and anxiety tests, we consider those to be on an interval scale. That if you were to get a 0 on a IQ test, we wouldn't necessarily consider that to be the absence of IQ. We would just consider that to be a very low score, that we can't measure any lower than that because we are limited in the types of testing we were able to do. And so we would just consider 0 another point on the scale, albeit a low point. And so, and same with depression, we would consider if you took a depression questionnaire and got a 0, we wouldn't necessarily say that's the absence of depression. You probably have a very low level of depression, but that's not to say that somewhere inside there isn't some little bit of sadness that we're just not measuring. So if we were looking at examples of variables and their scale of measurements, if we wanted to do a cookie study, because of course, who wouldn't want to do a cookie study? I might ask you, what is your favorite type of cookie? That would be measuring that variable on a nominal scale, because you would give me a name. You would say, my favorite cookie is Oreo or Chips Ahoy or oatmeal raisin, and we'd be getting names, named category data. Ordinal, maybe I give you 3 cookies and ask you to put them in rank order, favorite to least favorite. So I have you eat an Oreo and a Chips Ahoy and an oatmeal raisin cookie, and then you put them in order. What do we know? Maybe someone says Oreo is my first favorite, Chips Ahoy is second, oatmeal raisin is third. Well, I certainly know you like Oreo more than Chips Ahoy, but how much more? I don't know. It could be they were very, very close and you like them both and just Oreo barely kind of won out for first place. Or it could be that Oreo is your very, very favorite cookie and everything else is very far below that. That's the rank order scale. Interval, I could see what temperature is the best temperature to eat fresh baked cookies, right? We know temperature is on a interval scale because 0 is just another point on that scale. And ratio, how many cookies are left? Maybe I put you in a room with lots and lots of cookies and say, eat as many as you can in 5 minutes. And then we count up how many are left. Well, that's a ratio number, because if there are 5 left, there are 5 left. If there are 6 left, there are 6 left. And if there is 0 left, right, 0 means 0. That's the absence of cookies. All right. Once we kind of decide how we are going to measure our variables, what scale of measurement, we have 2 types of variables, and we are going to be talking about this again through the entire class. We have independent variables and dependent variables. And what this means, when we have an independent variable or an IV, this is the variable that you manipulate as a researcher. This is the one that you are choosing its values and you're manipulating. If I want to study what's the effect of temperature of the classroom on test performance. So I have some students take a test in a room that's 70 degrees, and some students take the same test in a room that's 90 degrees. Okay, the manipulated variable, that's the independent variable, in this case would be temperature of the room. It's what I'm manipulating and I'm thinking is the cause of a change in test score. So the independent variable is what you manipulate, and I choose the values, right? As the researcher, I could have people in a room that's 70 degrees and the other room could be 90 degrees. I could have picked a room, having students take a test in a room that's 60 degrees and the other students in a room that's 100 degrees. Or I could have 4 rooms and have a group of students taking the test at 60 degrees, another group taking the test at 70 degrees, another group taking the test at 80 degrees, another group taking the test at 90 degrees. I'm picking that. That's the independent variable. The dependent variable, or the DV, that's the observed variable or the measured variable. So in my study on room temperature on test score, my dependent variable is test score, right? I'm measuring by how many questions some students get right, the response. And this would be the effect if we're thinking of cause and effect. The independent variable is the cause. Temperature of the room, I think, is going to cause an effect or a change in the dependent variable. And again, you can think of the dependent variable. Your score on the dependent variable is dependent on your group in the independent variable. Are you in the 60-degree room or the 90-degree room? Okay. So an experiment measures the effect of the, there's a little sound effect, independent variable on the dependent variable. For example, does color of a paper a test is printed on, white paper versus blue paper, influence students' test scores? Think about this for a second. What is the independent variable and what is the dependent variable? So hopefully you've thought that the independent variable is the color of the paper. That's my cause, that's what I'm manipulating. And I think that that's going to change the scores on the dependent variable, which is student test scores. And in fact, another term that we're going to use, the independent variable, is color of paper. That's what I'm manipulating, color of paper. And then if we said, what are the levels of the independent variable? That would be the groups. So we have white paper versus blue paper, the levels of the IV. Okay, so the independent variable is what you manipulate, in this case, color of paper, and the levels are the groups, white versus blue. It wouldn't be right to say the independent variable is white and blue paper. The independent variable is color of paper, that's what I'm manipulating, and the levels in this case are white versus blue. The levels could have been blue versus green or red versus white versus blue. It's anything. Okay, so the independent variable is the variable you manipulate. It has to have at least 2 levels. You have to compare at least 2 groups. The dependent variable is the variable that you measure, and you think that its score, your score on the dependent variable, is caused by the independent variable. And a confounding variable, this is more of a question and a concept that you'll talk about in research methods, but a confounding variable is a variable that you try to control or randomize away. A confounding variable is basically a confusing variable. It's something that you do not want in your research study, and if you end up with a confound in your study, that's a problem. So if I had 2 groups of students, and I was again looking at temperature of a room, and I had one group of students take the test in a 60-degree room, and one group of students take a test in a 90-degree room. And I found out that the students who took the test in the 60-degree room did better than those in the 90-degree room, right? So my independent variable is temperature of the room. My levels are 60 degrees and 90 degrees. The dependent variable is the test score. And I'd like to be able to say that the the temperature of the room has an impact on test scores. And, if it's really hot in your classroom, that has an impact on students' test scores. That's not fair. We need to be sure we have cool classrooms for students to take tests in. But if I had a confound, what if I found out that everyone in my 60-degree group had graduated college, and everybody in my 90-degree group happened to be in 10th grade? Well, that's a confound, right? I have education level as a confound because now I don't know. Is it temperature of the room that caused the difference in test score? Or is it education level? Because I have college graduates in my 60-degree room and 10th graders in my 90-degree room. You can see how that would be a problem. And so you would try not to have something like that in your research design. You would try to have equal level of education and age and all sorts of things, socioeconomic status between your two groups, so you don't end up with a confound. And you could think to yourself, if you had an experiment and you were trying to test a new medication to treat depression, so you have two groups of people who have been diagnosed with depression. One group, you're going to try this new medication. One group is not going to get the new medication. And let's say that the ones who get the new medication, their symptoms decrease compared to the other group. What are some confounds that you could think of that might make it hard to understand those results? What are some confounds that you would not want in terms of systematic differences between the groups? And that's just a question you could think about as you're studying. Reliability and validity, two more terms, and again, I know this chapter is full of definitions. The rest of the chapters are not like this at all. We start doing actual kind of working with the material. But when you do psychological testing, in order to get data, you want to use tests that are what we call reliable and valid. Again, this is something you'll learn more about when you take a research methods class, but if you're using a measure like a depression questionnaire or an anxiety questionnaire or an IQ test, a reliable measure means that your test or your measure is consistent. And you need your tests to be consistent. They should give you a consistent answer each time you take the test. So if you think about just a regular old bathroom scale, if I put my daughter on the bathroom scale in the morning and she weighs 50 pounds, and then I take her off the scale and put her right back on the scale 1 second later, nothing's changed, and now it says 100 pounds. And then I take her off the scale and put her right back on the scale, and again, nothing's changed with her, but the scale now says 2 pounds. This is not a reliable measure. It is not consistent. What would you do with that scale? You would throw it away, right? And so that's the case with psychological measures as well. You want to be using a IQ test that if I give you this IQ test today and you get 100, that's the average for an IQ test. And then tomorrow I give you the same IQ test and nothing's happened between today or tomorrow, you should also get around 100. And if you take it the second time and you get 150, super genius, that's not consistent or not reliable. Once you have a reliable measure, meaning you're getting the same results over and over and over again when you give someone this test, which is important, you also need the result to be, or the measure to be valid. And what we mean by valid is it actually measuring or testing what you want it to? And this is harder to figure out, particularly when we're thinking about psychological tests. How do we measure depression? How do we measure anxiety? How do we measure IQ? This is more of a thoughtful question. Is this a valid measure? Right? What kinds of questions would you want on a test of IQ? right? And we could all probably have a large discussion on what it means for what is intelligence and what kind of questions should go on that test. So you want to be looking at your test that you're giving your research participants and be sure it's actually measuring what you want it to measure. For example, if I were to say, I am going to create a new depression questionnaire, and the only question on the test is, are you sad? Well, that's not a very valid measure of depression. For many of you, if you've taken any other psychology classes, and if not, you will, there is a lot more that goes into a diagnosis of depression than just being sad. And there are plenty of people who feel sad who would not qualify as with a diagnosis of depression. You need a lot more on that kind of a questionnaire than just one question, are you sad? So as you look at research studies, you want to look at what measures they used. First, are they reliable? Are they giving you consistent results? And then, excuse me, validity. Do you think that the questionnaire or the test is really measuring what you want it to measure? And so a good variable should be both reliable and valid. It's an example from the Rorschach personality test. This is a personality test where we show people an ink blot. Here's an ink blot and say, what does this look like to you? And depending on your answer, some psychologists, the Rorschach test would say that we can tell you about your personality. And then you could think about, do you think that this is a valid measure, a valid way to measure someone's personality? Do you think I can tell something about your personality by what you see in this ink blot? And that's a question we could debate. All right, last thing for this chapter. This is a get out your calculator. And for this, if you have your cell phone calculator, that's fine. We're going to just break into a little bit of math because stats is a math class for the most part. And we're just going to practice. You might not remember any of this, and that's okay. I'm going to start teaching you from the very beginning. But we're going to talk about order of operations. You probably remember this maybe from high school math, and that might have been a long time ago. Order of operations, you start with whatever's in the parentheses. That's done first. Then you do any squaring or any other exponents. That's second. Multiplying and dividing is third. Summation, and we use this sigma as a summation notation, that's done next, and then any additional adding and subtracting. So I will tell you that the math that we do in statistics is not hard math. All you're going to have to do is add, subtract, multiply, divide, square, or square root. That's as hard as it gets. There are sometimes many steps, so you've got to be able to go through all the steps, but it's not more difficult than that. And so on this page here, and it's okay, everybody, no worries, I have some data, X and Y. So here are my two variables, X and Y, and each row would represent a person. So person 1 would have gotten a 4 on this variable X and a 3 on this variable Y. Maybe X is a reading test and Y is a math test. So this person got an 4 on the reading test and a 3 on the math test. Person 2 got a 2 on the reading test and a 6 on the math test. So we have 3 people. And I want to see if you can calculate these expressions. I'm going to say one more thing, that you will never in this class get a formula on an exam that we haven't practiced a number of times already through these videos. So you won't have to figure it out on the spot. This is more just for you to take out your calculator, see what you remember, and know that we're gonna just get into a little bit of math as we move through the semester. So if you would, try to calculate these and pause this video now just go ahead and work through these and then we'll go through the answers. So go ahead and pause this now. All right, now hopefully you've done your work. So sum of x, that's our first one. That sigma sign means sum of x, so all you're going to do is add up 4 plus 2 plus 7. 4 plus 2 plus 7 gives you 13. Sum of x squared, so first we do the exponent. 4 squared, remember that's our data, 4, 2, and 7. So, 4 squared plus 2 squared plus 7 squared, 16 plus 4 plus 49 gives you 69. Now if we add the parentheses, in parentheses sum of x squared, first you do what's in the parentheses. So 4 plus 2 plus 7, which is 13, and then you square it. That gives you 169. Sum of, in parentheses, x minus 1. So again, do what's in the parentheses first. 4 minus 1 plus, and this is the summation sign, 2 minus 1 plus 7 minus 1. So that's 3 plus 1 plus 6. That gives you 10. For any calculations that we do, particularly on a test, I'd want you to write out all the steps of your math problems, because even though it's easy, can be easy math, there's so many steps that it's easy to make a simple careless error. So instead of 2 minus 1 being 1, if you do 2 minus 1 is 2. And then you get 11. If you've at least written out the steps, I know that you knew what you were doing and you just made a careless error. So I'll take a small amount of points off, versus if I just see 11, I don't know how you got that number, and so I would have to take all the points from the problem off. Sum of x minus 1 in parentheses and then squared. So we first do our parentheses. 4 minus 1 plus 2 minus 1 squared plus 7 minus 1 squared. That's 3 squared plus 1 squared plus 6 squared. 9 plus 1 plus 36, or 46. And lastly, sum of x times y. Remember, if there are two variables written together, that's multiplication. And when you're multiplying x and y, you're always going to be looking at the people on the same row, x and y. So 4 times 3. And then this person's x and y, 2 times 6. And then 7 times 2. So remember, first you multiply 12 plus 12 plus 14, and then you add together. So that's the end of chapter 1 in Nolan, and we will go ahead and get also started with SPSS as well for another video in this section. Thank you all. Goodbye.